All right, so this is the lecture for section 5.2. I'm not going to read all of these. This is in the textbook. I think it can be found on page. Let me get to 5.2 here real quick. It can be found on page. Where are you? Page 281 in the textbook. So that's something that you guys can go back and kind of read. But basically, the gist of it is that if we pick a value within an interval, and the interval, of course, would be between A and B, and we find a critical number C, and you can go back to 5.1 so you can kind of look at that. Now, if that value is a critical number, then it could be a relative max if f prime of x, the derivative of that, is greater than 0 in the interval from A to C, and C being the critical number. And then also that f prime of c is less than 0 in the interval of CB. So in other words, if this is A, this is C, and this is B. And so in the interval of A, B, if it's greater than 0, in other words, if it's increasing and then decreasing in the next interval, then that value right there would be a relative max. Now, the opposite of this would be, of course, that it's switched up, right? So that means that in the interval, if it's less than 0, in other words, it's negative, and then positive on this side, then that value right there would be a relative min within the interval of AB. So let's do some examples. So let's go ahead and do number 13. And it's asking us that to find the x values for all the points where the functions defined as follows have relative extrema. Find the value or values of any relative extrema. So f of x is x squared minus 10x plus 33. So we know that f prime of x would be 2x minus 10. And so what we're going to do now is we're going to say, okay, where is f prime of x equal to 0, right? So we do 2x minus 10 is equal to 0, 2x is equal to 10, and x is equal to 5. So in other words, 5 is a critical number. So if I put 5 there, then these are my two intervals, right? So this is my interval 1 and interval 2. I'm just naming them for the sake of demonstrations here. So if you think about the intervals themselves, they're going to go from, this one, of course, would be negative infinity to 5, and then this will be from 5 to positive infinity. So we can pick a test point just like we did in the previous. So for this one, we can choose a test point of 0. So we're going to go ahead and say, okay, what is f prime of 0? And f prime of 0 ends up being negative 10. All right, so that means it's negative, so it's decreasing in this interval. And then for this one, we're going to go ahead and pick 6. So f prime of 6 is going to end up being equal to 2, which is, of course, this is less than 0, this is greater than 0, so that's going to be a positive. So then the next thing that we're going to do in order to find that value that we need is we're going to find f of 5. And f of 5 ends up being 8. So then there's a relative min of 8 when x is equal to 5. Let's do 5 right there. So let me just rewrite this here real quick so it makes so a relative min of 8 at 5. So in other words, the ordered pair 5, 8, it's a relative minimum. So this is how you do the first derivative test for a particular function. So let's look at number 16. Let me go ahead and rewrite number 16 here because I did not complete it. So 16 is f of x is equal to x to the third plus 3x squared minus 24x plus 2. F prime of x will end up being 3x squared plus 6x minus 24. And so we're going to go ahead and factor this. So it's going to be x squared plus 2x minus 12, which then ends up being 3 and then x plus 4. Of course, you're going to factor this for the sake of time. I'm just kind of doing this this way. So then f prime of x is equal to 0, right, when x plus 4 is equal to 0, or x minus 2 is equal to 0, which means x is equal to negative 4 and x is equal to 2. So that's where the derivative of the function that we were given is equal to 0. So then we're going to create our interval, right? So it's going to be negative 4. This is going to be 2. So then if you think about it, we have 3 intervals here, right? So we have negative infinity to negative 4, we have negative 4 to 2, and then we have 2 to positive infinity. So then what is going on there? So we're going to go ahead and pick a test value within each one of these intervals. So let's go ahead and pick f prime of 5, which will give us 21, which means that it is increasing, right? Here we're going to go ahead and pick f prime of 0, and f prime of 0 will be negative 24, which means that it is decreasing. And then the next one we're going to do f prime of 3, which is equal to 21, which means that it's positive. So therefore, the function is increasing on negative infinity, negative 4, and on 2 to positive infinity. And then it's decreasing on negative 4 to 2, right? So then this right here, this point here is going to be a max, and then this point here is going to be a minimum, right? We don't know exactly where those points are, but we're going to go ahead and calculate them now. And so what we're going to do with this is I'm going to find f of negative 4. F of negative 4 is equal to 82. And then f of 2 is equal to negative 26. And that makes sense, right? Because between the interval of negative infinity, negative 4, and 2, we have a relative extrema, which is a max, because it's increasing and then decreasing. And then for the interval from negative 4 to 2, between negative 4 and 2 and positive infinity, there's a min because it's decreasing and then increasing. So therefore, there is a relative max of 82 at negative 4, and there's a relative min of negative 26 at 2. And so that's how you do number 16. So the next one that we're going to do is number 19. So let me just kind of get to that one. So number 19 is the function is f of x is equal to x to the 4th minus 18x squared minus 4. And so f prime of x for this one would be 4x to the 3rd minus 36x, right? And so we're going to factor out of 4x, which will leave us with x squared minus 9. And then it's going to be 4x, x minus 3, and x plus 3. Let me just see if I can do this here in case I want to use both sides. And so f prime of x is equal to 0 when x is equal to 0 and x is equal to 3 and x is equal to negative 3. So then we have a nice interval here, which would be negative 3 and then 0 and then 3. So then this one goes negative infinity to negative 3, negative 3 to 0, 0 to 3, and then 3 to positive infinity. Right? Those are the intervals that we have. We're going to pick a test point in each one of these. Let me just make sure that I have this. So we're going to say, we're going to do f prime of negative 4. And then f prime of negative 4 will give us negative 112, which means that's decreasing, right? So f prime of negative 1 is equal to 32, which means it's increasing. And then the next one, f prime of 1 is equal to negative 32, which means it's decreasing. And then the last one, f prime of 4 is equal to 112, which means it's decreasing. Increasing, sorry. And so the function is increasing on negative 3, 0, and 3 to positive infinity, right? That's where it's increasing. It is decreasing. Sorry, my pencil froze here for a second. Let me see if it comes back here real quick. All right, I might have to get out and come back in. Nope. Hold on a second. Okay, maybe now it comes back. Froze on me. So I'm just going to kind of skip to this because I already did that, right? And so here we have negative 3, 0, and 3. So this is 3 to infinity, 0 to 3, negative 3 to 0, then negative infinity to negative 3. And I believe that we have picked f prime of negative 4 was 112, which is decreasing. F prime of negative 1 turned out to be 32, which means it's increasing. F prime of 1 is equal to negative 32, which means it's decreasing. And then f prime of 4 ends up being 112, which it's increasing. So this function is increasing on negative 3, 0, and 3 to positive infinity, right? It's increasing on those two, and then it's decreasing on negative infinity to negative 3, and then 0 to 3, right? And so then the next thing is to find the extreme, I'm sorry. So f of negative 3 is negative 85. F of 0 is negative 4. And f of 3 is negative 85. And so the next one is that it has a relative min of 85 at 3 and negative 3, and a relative max of negative 4 at 0. And that's how you do number 19 for this particular question. All right, let me see what's the next one to do. I apologize for that freezing here. So let's do number 22. So let me just kind of do here. So 22, the function for 22 is f of x is equal to 5 minus 9x raised to the 2/3 over 7 plus 1. And so f prime of x for this one is going to be 2/3, right? 5 minus 9x raised to the negative 1/3 over 7 times negative 9. And if we clean it up a little bit, it's going to be negative 6 over 7, 5 minus 9x raised to the 1/3. And so the critical number, since this can never, so f prime of x will never be equal to 0, this is a rational expression. We're going to find where is it undefined, right? And it's going to be undefined when 5 minus 9x is equal to 0. And x is equal to 5/9. And so when we create our interval, please be aware of this, right? It can't be 0 because the numerator can never be 0. My intervals then are going to be -infinity to 5/9 and 5/9 to +infinity. And so we're going to just pick a test point. So the first test point in the first interval is going to be f prime of 0, which is -0.5, right around there. So, but we know it's negative, so we don't really have to worry too much about the value. And then this is going to be 0.54. So it's decreasing on the interval -infinity to 5/9 and increasing in the interval from 5/9 to infinity. So increasing on 5/9 to infinity, and then decreasing on the interval of -infinity to 5/9. So it has a relative min. So here we're going to find f of 5/9, and f of 5/9 is equal to 1. Sorry, my iPad is really acting up today. Of 1. So it has a relative min of 1 at 5/9. And so that's number 22. Let's jump over to 27. So 27 is basically the same thing that we're going to do here. Let me go ahead and just kind of do this here real quick. So 27, f of x is equal to x squared minus 2x plus 1 all over x minus 3. F prime of x, if we kind of clean it up a little bit, is going to be x squared minus 6x plus 5 over x minus 3 to the second power. So then where is f prime of x equal to 0, right? It's equal to 0 when x minus 6x plus 5 is equal to 0, which will give us x minus 5 and then x minus 1. So then we got x is equal to 5 and x is equal to 1. Now, the next one is that f of x and f prime of x do not exist when x is equal to 3. So the only critical numbers here are going to be 1 and 5. So we don't have to worry about 3. We only have to worry about 1 and 5. So here's my number line. I'm going to put 1 there. I'm going to put 5 there. So this one's going to be -infinity to 1, 1 to 5, and then 5 to infinity. So for the first interval, we're going to go ahead and pick 0. Right? Let's go ahead and pick. So we're going to do f prime of 0 is equal to 5/9, which is positive. The next one is f prime of 2, which is going to be -3, which is negative, right? It's decreasing. And then the next one is just going to be f prime of 6, which is equal to 5/9, which means it's increasing. So it is increasing on -infinity 1 and the interval of 5 to +infinity. And then it's decreasing on the interval of 1, 5. So then the next thing that we're going to do is we're going to go ahead and say that the function f of x is increasing. We already have that there. Sorry, the function f of x. So let's go ahead and find. So f1 is equal to 0, and f of 1 is equal to 0, and f of 5 is equal to 8. So it has a relative max of 0 at 1 and a relative min of 8 at 5. So you have to be aware that in the interval between 1, 5, and 5 to infinity, it decreases first and then increases, which makes it a min. And then on the interval between negative infinity and 1 and 1 and 5, it's increasing and then decreasing, which makes it a max. Okay, so don't worry about the value itself. It's what's happening in between the two intervals, if you will. All right, that's number 27. And then we can jump over to number 30, and so let's do 30. So number 30, f of x is equal to 3x times e raised to the x power plus 2, which means that f prime of x is equal to 3x raised to the ex plus 3 times e raised to the e raised to the third, which means is going to be 3 times e raised to the x power times x plus 1. So 3e to the x is equal to 0. When e to the x is equal to 0, x plus 1 is equal to 0 when x is equal to negative 1. Now, e to the x is always going to be positive, no matter what. So the only critical number then is when x is equal to negative 1. So we're not going to use e to the x because that's always going to be positive. And so then we're going to have an interval from negative infinity to negative 1, and then negative 1 to positive infinity. So here we're going to pick f prime of 2, which is going to give us negative 3e raised to the negative second power, which happens to be less than 0, so it's going to be decreasing on that interval. And then f prime of 0 is going to be equal to 3, which means it's going to be increasing on that. So f is increasing on negative 1 to positive infinity, and f is decreasing on the interval of negative infinity to negative 1. So f of negative 1, right, because we have to find now the critical number, f of negative 1 is about 0.9. So then there's a relative min, again, decreasing and then increasing, it's a relative min of 0.9 at negative 1. And that's how you do number 30. So let's jump over to number 43. Just get to number 43 here real quick. So number 43 is a word problem, and it says, let me go down here with it so I can kind of get it. So number 43, it says, find the number of Q of units that produces a maximum profit, the price P per unit that produces the maximum profit, and then the maximum profit itself. So they're giving us that C of Q for number 43 is equal to 80 plus 18Q. And then they said the price function is going to be 70 minus 2Q, right? Now, in this case here, they gave us the price function, but we need the revenue function, right? Which means it's going to be 70Q minus 2Q squared, right? Because I have to multiply the price function. So remember, the revenue function is equal to Q times the price, the quantity times the price. So I have to take the price and multiply that times the quantity. So then the easiest thing to do, in my opinion, is to find, okay, so this is going to be, if I find the derivative of C, if I find C prime of Q, it's just going to be 18, right? Our prime of Q is going to be 70 minus 4Q. And so, make sure I got all these right. So it's going to be 70 minus. So then, the profit function is going to be 70Q minus 2Q squared minus 80 plus 18Q, which is going to end up being negative 2Q squared, right, plus 52q, and then it's going to be minus 80. Now, since the graph of P is a parabola and it opens downward because A is negative, remember, parabola is ax squared plus bx plus c. If A is less than 0, then it's going to open downward, right? So we can just to find a q value at this point, we're going to find the critical number, right? And so here you can see that P prime of q is going to be 70 minus 4q minus 18, which is just going to be negative 4q plus 52, right? So where is P prime of q equal to 0? It's equal to 0 when 4q plus 52 is equal to 0, which means that q is equal to 13. So the number of units that produce the maximum profit is 13. So this is produces max profit. And so the next thing is, so this is part A, sorry. Part B, right? If q is equal to 13, then P is equal to 70 minus 2 times 13, which is going to give us to 44. So then the price that produces the maximum profit of $13, the maximum profit would be $44. And then the next one would be, what is the maximum, so the price that produces the maximum profit would be $44. Now for part C, max profit. For part C, they're asking us to find the profit. What's the maximum profit, right? So that's going to be P of 13, which ends up being $258. So the max profit is $258. That's how you do number 43. Let's see what we have. We can jump over to 40. If I do 44, is basically going to be the same as 43, so I'm going to leave 44 for you as extra. And let's jump over to number 48. So number 48, it says the total profit P of X in thousands of dollars from the sale of X units of a certain prescription drug is given by, so let me jump over to 48. And so it's going to be P of X is equal to the natural log of negative x to the third power plus 3x squared plus 72x plus 1. And then x basically it says is going to be in the interval from 0 to 10, right? So the first one is part A is find a number of units that should be sold in order to maximize profit. Right? So for part A, what we're going to do is we're going to find P prime. So P prime of X, if you remember, it's just going to be G prime over G of X, right? So then this is going to be negative 3x squared plus 6x plus 72 over negative x to the third plus 3x squared plus 72x plus 1. And so we can go ahead and say, okay, we're going to factor this a little bit. So I'm going to have a negative 3 out here. I'm going to have an x minus 6. I'm going to have an x plus 4. And then this is just going to remain the same, right? So I just factored out my numerator because I want to find out where is P prime of x equal to 0. So we know that x minus 6 is equal to 0, so that's going to be 6. X plus 4 is 0, so that's going to be negative 4, right? We're just finding out where is equal to 0, which means when is the denominator equal to 0. And so the next thing is, since negative 4 is not in the interval, right? The interval that they said that we're dealing with is going to be 0, 10. So then, in this case here, we we don't use -4. And so that fails to exist at that particular value. So now the next thing is that we know that if I plug in -4, I'm not going to get a value. I'm going to get -0.14, and then I'm going to get 10.3 or something like that. So this is not in the interval, so therefore we don't worry about -4 because it has to be in the interval from 0 to 6. So the critical number is 6. 6 is your critical number. And so what we're going to do when x is equal to 6, right? We're going to do the same thing that we did before. And so this was going to be 0 to 6, right? And then this is going to be, I'm just going to do it this way just for the sake of it. And then 6, 10, right? So f prime of 5 is going to be 27 over 311. Oh, p. P prime of 7 is going to be -11 over 103. So that's going to be increasing and decreasing. So then for part D, we're going to go ahead and find P of 6. And P of 6 is 5.784, which is $5,784. And so that's part A, part B, and part C. So remember, it's increasing and then decreasing, which makes it a max. All right, let's go to the next one, which is number 49. So what I'm going to do is also I'm going to leave 49 for you guys. So that's 2 of them. Basically the same thing as what we have here. So the next one is number 50. So number 50 basically says the demand equation for one type of computer networking system is given by P is equal to D of Q, which is 500 Q times E raised to the -0.0016 Q to the second power. Now the P, the price is in dollars, Q is the quantities in servers sold per month. Find the values of P, Q and P that maximize revenue. So for number 50, P is equal to D of Q, which is 500 Q times E raised to the -16 Q squared. So remember, the revenue function is equal to price times Q, right? Which means that the revenue function in this case is going to be 500 Q squared, right? And then E raised to the -0.0016 Q to the second power. So I'm going to find the derivative, right? So we can go back and look at for the derivative. We're going to have to use the product rule and all those different values. Formulas. So basically, when we do that, we basically end up with the following. So it's going to be 500 times E raised to the -0.0016 Q squared times 2Q. And then we can go ahead and leave it right there for now. We're going to go ahead and set that equal to 0. So where is RQ equal to 0? And so then when I plug in these values, when I set this equal to 0, I get that Q is equal to 25. Now, if Q is less than 25, then R prime of Q is greater than 0. If Q is greater than 25, then R prime of Q is less than 0. So P has a max value at Q is equal to 25, right? So I kind of skipped a little bit here to find the intervals and all that good stuff, but this is what you're going to do. And so then the next thing that we're going to find is the price. So P is equal to D of 25, which is about 4,600. So max revenue occurs at when the price is about $4,600 at a quantity of 25 servers per month, or computer systems. Sold. All right, the last one is 51. So let's look at number 51. So number 51, it says, suppose that the cost function for a product is given by C of x is equal to 0.002 x to the third power. And so plus 9x plus 6912. And so find the production level of the value of x that will produce the minimum average cost per unit. So we're going to have to find C bar of x, which is 0.002 x to the second power, plus 9, plus 6,912 over x. And so C bar prime of x is just going to be 0.004x minus 6912 over x squared. So then C bar prime of x is equal to 0. When we set it equal to 0, right, we set this equal to 0, and then we get that x is equal to 120. So of course, this is what you have to do. And so the answer then is a 120 units will produce the min average cost per unit. And that's the end of 5.2. Thank you.